bumbling around and have realized homework 1.4 needs to be done and is going to be turned in today. Okay? Why do people irritate? By the way, puzzles are done with your brain, not your muscles. Just so we got that clear. So, homework 1.4. Shh. Make sure you guys have that ready, ready, while you work on our warm-up for today. So, I guess I should shapes. So draw the shapes without lifting your pencil or going over a line more than once. You may have seen one or both of these before. I am not going to draw it right now how you would draw it, because that would give it away. Okay. First shape. A classic. Okay, second shape. No. I suppose not. Okay, so those are the two shapes for you to try and draw. Again, so like that means I can't go like this, right? I can't draw over here around the triangle and then go back over that line. Right, so once you've drawn a line, that's it. Okay. Also, I'm gonna make this last call. If any of you guys wanted to apply to that Hollywood Arts Collective to do anything. Again, the idea being like if there's anything that you want to make, manufacture, produce, they will give you the resources and the support to do that. Okay, so it doesn't have to be like, oh, I want to do a drawing, but if you know, whatever you might want. If any of you have these and you want to give them to me, please do. If you want an extra one because you're like, oh yeah, I forgot I wanted to do that, I still have some extras. I do need them by the end of the day, though. Okay, today's kind of the last bit here. All right. Think about that. How about homework 1.4? Let me know if you get those. You can't go like. Some people go like, you can't like. I don't know. Right here. Now I'm stuck because I have to like follow. Come do it. Omar, you do it. Come on, Omar.
I'll do it. I don't do it.
Come on, Omar, do it.
I'll do it for him.
Why?
Omar,
Kale talks too much.
Huh?
Kale talks too much. Okay.
I don't got it.
Okay, Kale. Yeah. Oh. Yeah, of course. You guys have to decide if you really did it a different way.
I can't see the image.
Abby, is this different from yours?
It's like Abby's. It's a racing.
It's basically just a different order.
I did mine differently.
What? You got a different way? Yeah. Or the second one? Hey, no hands, don't touch him. No. No. Just go away. Good job, Kale. Thanks. Jolie, you're up. Greasy and what? Did you guys see that? Hold on. I've never ever never even tried that.
Well, you don't even cross it out.
Jeez.
I'm sure you don't yell at her when she uses her hands.
My hands are quickly use one finger. She wasn't going like this.
I'm racing at that.
Awesome. I've never seen it done like that.
No, look at
Anyone on this one?
No. I did it different. Hey, do your way.
Hold on, we're moving on. Anyone did this way?
I used a loophole and I got it.
No one.
Then you shot me down.
No loopholes. No one. Okay. All right. What's next?
Aren't you gonna show us now?
Why would I give it away? I'm not gonna give it away.
This is a learning environment.
Cool.
Teach us how to learn. Teach us how to do it.
You're all right. I'm not gonna show you.
Not gonna bug you for the rest of the day.
Good.
I'm gonna die.
That's exactly why I'm not gonna tell you.
Focus.
How about we just do reverse psychology?
Um,
We don't want to.
I don't think reverse psychology works on teachers.
I'm a psycho. Psychology doesn't work on me.
Now we can't focus.
Hey,
Hey, you
Kane. Yeah, exactly.
I'm doing
I want to talk real quick about solving. So we're going to just talk real quickly about this. We're going to move through today fairly quickly. Through the planned activities fairly quickly. We're going to talk about some situational solving. And because you guys have all spent time talking about your homework, we're going to talk about your homework as well. Okay? Okay. From homework 1.4. So. When we're having these like situations where there's two different situations going on, there are three options for solving. Okay, there are three options for solving. Yeah, we talked about it on the board yesterday, and now we're putting this in our notes. Right? Three is the magic number. Hey. Okay, so we talked about this with the whole Ben and Jerry problem, not the ice cream thing, although that does sound delicious. Using the Oaks Park problem, you could use tables. And from the Oaks Park problem, right, there were two different options or plans for buying the tickets. The first one was that each student can buy a ticket for $1 each. Okay, so, or I'm sorry, $12 each. Hey, stop talking so much. So on option 1, and you guys should have made a table that said, okay, cool, if 0 students go, and this is the number of students for X, and this is the price, because how much you pay depends on how many students are going. Right? If no one goes at $12 a ticket, how much did you spend? 0, right? Fairly straightforward. And if one person goes, you've spent $12. If 2 people go, 24. 3 people go, 36, etc. Okay? And for option 2, it says, well, we can give a discounted group rate, but you have to pay the one-time group fee, right? The one-time group fee of $24 means that even if no one goes under that option, you've still paid $24, even if no one goes. But if one person goes, right, and you have the $24 option plus $8 per person, right? So this should be the same work that you guys did last night or the night before on your homework. At $1 a person, this would make at $8 a person, they would be at $32 if one person went. And if 2 people went, they'd be at $40. Because here on option 2, it's a flat fee, or you might even say a fixed cost of $24 plus the $8 per person. So if 3 people went, it'd be $48. Now, what are some positives to doing a table? Omar, pick your head up, please. Positives to using a table. Yahoo. Okay, you can see where the numbers match up. Do we see it yet? No. So that might be a negative, but you can see really easily where the numbers match up. Right? Ansel.
It's more exact than looking at a graph, like where you might be in the general area of the exact number, but
Yeah, I think I would agree. It could be more exact. When is a table not so good though? When big numbers. Fair. What else? Decimals. What about, remember the problems yesterday? Some of them had good tables and some of them had bad tables. When's a table not so helpful? Do you pick your head up, please? Xander? What do you mean by that?
Like, if the table doesn't include the Y or the X.
Okay. Do you need those though? Because what are we trying to find? We're not trying to find the intercepts. If we're talking about 2 lines, what are we trying to find? No, not to answer the question. If I'm thinking about 2 situations, you already said, Yahi, you're trying to see when the numbers are what? The same, right? Or if there were 2 lines, what am I looking for? Where they intersect, right? Not the X and Y intercepts, but where those 2 lines intersect. Okay, so those are some tables. Of course, that's the first option, 1, tables. The second option, 2, graphs. Or a graph, I guess. Now you could put these on a graph. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. I'm just making a small graph. And if I put these situations on a graph, I have 0, 0 for option 1. 1, 12-ish, 2, 24-ish, 3, 36-ish. And so if I were making my graph for option 1, it would look something like this. And if I'm making my graph for option 2, 24, 32, 40. Option 2, you might have something like this. Right? You could use graphs. Plus side to graphing? Is there a plus side to it? Is there a reason why graphing might be nicest or easiest? You can see where they intersect, but if I don't graph carefully, it might not be exact, right? It might not be very accurate. The one thing you can tell, though, from a graph is, Kale said the growth, you can tell which one's growing more quickly. And I can easily see, from a table I might be able to see where they intersect, but from a graph I can really see, okay, great, here's where they intersect, and I can see which one's going to be more expensive from there on out, right? It's easier to kind of compare how steep the two options are. Okay, but you know, you might prefer to use tables, you might prefer to use graphs, and that might depend on the problem as well. Kane, pick your head up. The third option is using some equations. Okay, option 1 said it was going to be $12 per person. $12 per person for option 1. 12x. If 4 people go, 12 times 4. If 8 people go, 12 times 8. $12 a person. Simple equation. Option 2 said fixed cost of $24 plus $8 per person. Right? Option 2 said $24 no matter what, $8 per person thereafter. And if I wanted to make life easy, again, we're trying to figure out, the question was, when are the two options equal? If I want to know when the two options are equal, what can I do with these two things?
No, you do.
Yeah.
Solve
Hold
it,
on, no,
right?
no flipping yet. First I need to make a new equation. Right? I need to make these what?
Equal.
You gotta make them equal to each other. Right? If I wanted to solve this, I can now solve that equation. Why don't you guys go ahead and solve that equation mathematically? Because I didn't really see very many people, maybe one of you, who actually set up two equations, put them equal to each other, and is now solving it. You could see it from the table for this one, and yeah, you could see it from the graph for this one. But we're going to try and work on this skill when it's a little easier. So when the table and graph suck, we know how to solve it. By the way, this solving is a warm-up for your quiz. I hope it does. Very good. Write this down. Solve this. Four x means 4 times x, and the opposite of multiplication is division. And then he said some more stuff that I forget. So those guys divide, and we get, of course, that x is equal to 6. Which, Henry, what'd you notice?
I didn't match up at the table on number 6, they're the same, they're matched up on the 6th person.
Right, that if done correctly, all 3 of these methods, you guys extended the table out on your homework. You should have seen at 6 people, it'd be the same cost. On our graph, it's pretty close, but I didn't do a very good graph, right? So on the table it should be 6, on the graph it should be 6, on the equation it should be 6. So having multiple methods mean you should also be able to tell when you're right, because like Henry said, it should be the same no matter which way we do it. Okay? I don't really care which way you do it, so long as you're correct. And if you're not sure if you're correct, have maybe at least 2 ways you can do it. So that being said, I'm going to give you a little more challenging situation than you had last time. And you guys can kind of choose which method is going to work best for you. We're going to kind of dive into when would I want to use each method. There's only one situation. So I'm asking that you tend to it, do it well, accurately. This is a similar thing, situations like last time. We did posters and flowers.
Oh, yeah.
They were running
He has
by
anger
Wednesday.
advantage.
That'd be fun.
I wanna go run for
Add these equations.
Yeah.
Now here's the deal. Here's the deal. Those 3 methods we talked about a minute ago, tables, graphs, and equations, can all also be done on here. The more you know how to use this, I'm like telling you gold right now. The more you know how to use this, the more you can get away with. Because I can use a table and a graph all on my calculator, and it doesn't make any sense to do it by hand if I here. So we should be okay with these equations. Noticing again, if June runs 1 mile every 8 minutes, that would be 1/8, right? 1 mile per 8 minutes. Damon over here would be 1 mile per 5 minutes. Okay, so once we get those equations, that's the part that we need to use our brain. Now, over here on our graphing calculator, some of you know this, some of you don't. All of you are going to know this henceforth. Looking, please. To enter equations in, I use y equals. If you have equations in there, you need to clear them out. Make sure you hit the y equals button. Y equals. You're following along with me right now.
Yes, I am.
Okay? I'm typing in June's equation. 2 plus, always put parentheses around a fraction. 2 plus 1 divided by 8. 1/8. Always put parentheses around a fraction. And for x, we use this x button right here. The one that has an x, a t, a 0, the thing. Okay? So there's June's equation. 2 plus 1/8 x. This one.
It has all those Greek characters.
Yes. Okay. Next, if I wanted to enter my other equation, same. 1 plus parentheses around the fraction always. And there's your xt again. Enter both of them. So you should have both of these equations in there. Right, I have both equations in there. Are we okay? Now, this blue line right there says table. If I want to get any of the blue keys on my calculator in general, I have to press the blue button. Okay? So I have to press, if I press second graph, I'll get to my table. Now, if you're at a crazy number, you can change that. This blue right here says table set. So if I change my table, I can start at 0 again. So if you wanted to change where your table starts, that's under table set, it's blue. But in your table, you should have something like this. You should have something like this in your table. So you guys, did you press table? Show him, don't do it for him. Show him, don't do it for him, Kale. Okay, Kale, then don't. I'll do it. Don't. Does everyone have this on their screen? Except Arcane. Now you could just keep scrolling until you got to 0. Okay. So we could go like this. Hey, when tables are nice, you could scroll and find out where they're equal by looking at where these two are equal. They're not equal at 13. They're pretty close, but look, they're not equal. So some of you might say, okay, cool, next one. Okay, I just want to look at the graph. Don't talk while I'm talking, please. I just want to look at the graph. So if we just hit graph, right, obviously you can also graph a line by hitting graph. And we still can't see where they intersect. So we're going to change our window a little bit. Is everyone here? Yes, we've graphed? Huh? Okay. Hey, look. If your graph doesn't... Stop. If your graph doesn't look like this, zoom 6. Zoom 6. Zoom 6 if your graph didn't look like that. And we should all look the same. Now, the other thing we know we don't need to know negative minutes or negative miles. Under window, go to window. Window. We don't need our x min. Stop. We don't need it to be negative 10. Let's make it 0. Let's make our max go a little further to like 15. Okay, same thing, the y minimum, that's the distances. They're not running negative miles. I can make my y min 0, and I'll just leave it at 10. So make sure your window, sometimes you guys are going to get really good at setting your window on calculators. And then when I hit graph, I can see my two lines again. And I can start to see where they cross. Here-ish. Although I still don't know. Still don't know. Right? So even though the calculator is an accurate tool, it helped me with a table, it helped me with a graph, I still can't see exactly where they cross. Right? What I can do though, if my table and graph have both failed me, what can I do with these two equations? Yeah, put them equal to each other. Okay, since table and graph both fail, we are going to solve. Your calculator doesn't solve for you. No, because 13 is not the answer. I know that you and I already worked on this, Yahi. You don't need to tell me that. Okay? So here, I now need to solve. The calculator, we've exhausted our possibilities. I need to solve this. You should be writing this down. When I'm solving, we normally like to have our x's on the left. So I'm going to bring 1/5 over to this side. How do I do that? Go ahead. What? Minus 1/5. I don't care that it's a fraction. It's just a number. And if I'm trying to do 1/8 minus 1/5, again on my calculator, just use parentheses. 1/8 minus parentheses 1/5. If I know how to use my calculator, I don't have to be all fancy with fractions. I can just subtract them because they're just numbers. 1/8 minus 1/5, and I get negative 0.075. I'm just going to leave it as that decimal. Again, it's just a number. So I would have 2 minus 0.075x is equal to 1. So now what do I do? Yep, bring the 2 to the other side. Subtract the 2. So we have negative 0.075 is equal to negative 1. have to do? Divide by what, you Jolie? Negative 0.075. Divide by negative 0.075. And if I do negative 1 divided by negative 0.075, I get my answer of 13.33 minutes.
Keep going up, right?
And that's nice that they taught you that in elementary or middle school, but we don't use it. I'm not calling you out. I don't know why they we don't use it. We round
Wait, you don't use one hand.
the repeating bar because it doesn't do anything.
It says you keep repeating.
I don't care if it keeps repeating. No, what I'd rather you do if you want to talk about a bar, write your answer like this then, and know that 1/3, 0.33 repeating is 1/3. Or, or better yet, what's 1/3 of a minute? Right? If you want to get talking about what you should do, I don't care about a bar. Okay. So, look again. One of the methods, like here, when it's a crazy decimal, a never-ending decimal, you couldn't get that from your table. We couldn't even get that accuracy from our graph. Sometimes we can, but we should be able to see, like we saw in our table, and Lorenzo said it's really close to 13, right? They're really close, and they should, like Henry was saying earlier, they should all line up, and you can see they're kind of lining up because it's really close to 13, and if I go 20 more seconds, that'd be right where they cross. Okay? Alrighty, so we are going to move on to working on your quiz, so you can keep your calculator, but everything else needs to be put away, please.